So hey everyone, welcome back to my channel. This is Lakshay here. So today we are gonna start with a new question, that is lead code question number 148, which says sort list. So in this question, this is a medium level question. So what it says, given the head of a linked list, return the list after sorting it in ascending order. It means we will be given a list, linked list, and we have to sort it and return its head. Which means, let's take this example which we have already given. We are given this list and we have to return it in the sorted manner like this: 1 2 3. So there are various methods to perform this, but the best will be merge sort. We will perform merge sort on our linked list to get our linked list in sorted order. Okay, so how can we perform this? Let's see. So for this, let's again write our list here: 1 and 3. No, wait a second. Let's write it down like this. So for this we will break our list into two equal halves. So for that, how to break? First of all, our head will be pointing to here. We will create a slow pointer and a fast pointer. Fast pointer should be pointing to us, slows next means our head next. Okay, now we'll start our traversal, in which our slow will move to one step ahead and our fast will move to two step ahead till our fast next is equals to null or our fast is null. Okay, so let's see. On first iteration, our slow will move to slows next and our fast will move to fast dot next. On first iteration here, we can see that our fast next is now null. So we'll stop our iteration and we will create a new pointer mid, which we will place on slows next. So our slow is here, its next is pointing to here. So we will place a pointer mid and our slow will now point to null. Our slows next will now point to null. Okay. So now we have created two lists. One is this and another is this. Okay. So now we will create, again call this function, that is our original function, which is merge sort. We will again call this function for now two list. That is, first we are having 4 2 and this, and another is 1 3 and this. Cool. Now we will again create the same: one head, a slow pointer and a fast pointer, a slow and a fast pointer. Now we can see that we cannot go into our while loop, which says that our fast should not be equals to null and our fast next should also not be equal to null, because we can see that our fast next is null here. That's why we will simply create a mid pointers on a slow next, that will be here, and our slow will now point to null. Cool. Now this side also it's same, so we will create mid here and a slow will now point to null. Okay, so now our list look something like this: 4 2 and here 1 3. Oh, sorry, 1 and 3. So we can see that our all elements are separated. Now we will start to merge them back. We will traverse backwards and we will merge them. So first of all, for this we will create a new function, that is merge, where we will pass our this and this. So when we pass them back, let's see downwards. When we pass them back, it should give us 2 and 4 and x in sorted manner. And simply let's see how we are getting this. Okay, for this, let's suppose this is our L1 and this is our L2. Okay, this is our two list. L1 is pointing to list 1 head and L2 is pointing to list node head. So first of all, we create a dummy pointer which will be pointing to a dummy node, that is 0, and we will also create a tail pointer which will point to this dummy. So now we will compare that the L1 value and L2 value. If L1 value is greater than L2, that means our tail will point to L2, that is 2 here, and then our L2 will move to L2 dot next, that is here null. So now our L2 is pointing to here, and our tail will point to tail dot next, that is now our tail is pointing to here. Okay, so now what we will do, so there will be a condition here that L2 should not be equal to null and L1 should not be equal to null. Then on we will keep on traversing, but now we can see that L2 is equals to null. So now what we will do, we will simply check that if there is any element left in L1, then tails next will point to L1, or else it will point to L2. So we can see that there is an element left, and in this case we will only have one list left, either L1 or L2. That's why only now we have break down our loop, means our condition, that is either our L is 1 equals to null, or our L2 is not equal, or our L2 is equals to null. That's why we have break the condition. So that's why here we can see our L2 is null, that's why we have break that condition, and now we are move to our next step, that is either L1 or L1 L2 is there. So we can see that in this case we have L1 left, so our tail next will point to L1, that is our 4. That's it, and our 4 next is points to here. So we can see that we got this list. We will simply return dummies next, which will be this as new head. So we will return this in sorted manner. Simply how we will return this, it will also be like this, dummies next will point to here, then this, and then we will return dummies dot next, means from here, list from here. So at last, after merging these two also, we will get a list something like this: 1 2 3 and 4. And then again we return our dummies. Here are dummies, and dummies next, means these are head. So hence we will get our desired list that we want: 1 2 3 4, 1 2 3 4. Cool. So let's write down its pseudocode. So first of all, we will write our main function, is merge sort function. Okay, we will pass our head, and we will check if our head is null, or if our heads next is null, we will simply return our head. Else what we will do, we will create two pointers, that is slow, which will point to head, and fast, which will point to head dot next. And then we will keep on traversing while our fast is equals to means not equals to null, and also our fast next is not equals to null. Then our slow will move to slow dot next, and our fast will move to fast dot next. Great. So after this iteration, we will see that our slows next is will point to, we will create a sorry. So now we will create, like we discussed, we will create a mid pointer which will be placed at slows next, and our slow next will now equals to null. Okay, great. So what we will do now, we will create two lists, that will be our L1 and L2, and for L1 we will call again the merge sort function, and we will pass our head, and a merge sort function where we will pass our mid. This will help us to break these lists into much shorter, to get at last we'll all get the single elements, and then we will merge them. Then we will merge them in the sorted manner and return. Wait a second. We will simply return them after merging. We will pass L1 and L2. Great. Now let's talk about the merge function. Okay. So here is our merge function where we will pass our list L1, L2. Then first of all we will create a dummy pointer, that is a dummy, which will be new list node 0. Then what we will do, we will again create a tail pointer which will point to initially our dummy. Then what? Then we will start our traversal, that if while our L1 is there and also our L2 is there, means both should be there, none of them should be null. Then we will check if L1 value is greater than L2 value, that means our L1 is shorter, so our tails next will point to L2 and our L2 equals to L2 dot next. Else means our L1 is shorter, that means our tails next will point to L1 and L1 equals to L1 dot next. Now we have to also move our tail pointer, so our tail will always move to tail dot next in both the cases. That's it. At last, what we will do, we will return our dummies next, but first we will check if any remaining is left or not. So we will check, we will simply say that our tail dot next will point to L1 if L1 is there. Sorry, if so tails next will point to L1 only and only if L1 is present, otherwise it will point to L2. Okay, so at last we will simply return our sorry, we will simply return our dummies next. So that's it. This is our pseudocode for this problem. So first of all we'll create this function, then we will create this function. Okay, so let's discuss its time complexity. So the time complexity is, let's write down here. So the time complexity for the sorting part is, we all know, for dividing, the time complexity for dividing our linked list will be log n, and for, let's write here divide, and the time complexity for the for our merging is log n, means only n, we go for it. So the total time complexity will be big O of n log n. This is a time because it's our dividing and it's our merging time complexity. So on total it will give us big O of n log n. This is our time complexity here, which will be our final time complexity. So now, so that's it. Try this question yourself, and also if you face any problem, I will paste the official code below. So here is our code, like already discussed. First we will check its head is, this is our base case, so that our recursion will stop. Then we will create pointer slow fast, then simply slow equals to slow dot next, fast equals to fast dot next, then mid pointer, then slow next equals to null, then again creating two, and then merging at last. Or then here is our merge function, so you can study it later on. So that's it. This is all about this problem. Thanks for watching. Bye bye.